Welcome back everyone. Today I'll be doing partial differentiation where I'll be differentiating composite function using partial derivatives. Now, the process that I'll be using is chain rule and we have two cases. This week I will do the first case and next week I will look at the second case. Now, suppose we have z, which is a function of x and y, and it's considered to be differentiable function of x and y, where x is a function of t and y is a function of t. So both of them are differentiable functions of t. Then z is a differentiable function of t, and we will apply the following chain rule. We differentiate z with respect to t, and we will find the partial derivative of f, which is this function with respect to x, times we differentiate x with respect to t, that's what's happening here, plus the partial derivative of f with respect to y, and we will differentiate y with respect to t. Let's look at an example. Now, this example, we have z equal x squared y plus 3xy squared, where x is equal to sine 2t and y is equal to cos t. So you can see that z is a function of x and y, and x is a function of t and y is a function of t. Now, here I need to find derivative with respect to t for z, and applying the chain rule where I will differentiate z with respect to x, which is a partial derivative of z with respect to x, and I will differentiate x with respect to t, and I will also have plus partial derivative of z with respect to y, and then I differentiate y with respect to t. So let's start. So I need to find the partial, I will put it here, the partial derivative of z with respect to x. And in order to do this, I have to go ahead and look at this function. We treat y as a constant, so it means I differentiate x to get 2x. So this will be 2xy. So I'll have 2xy here, plus I will differentiate this part, but with respect to x, I treat y to the fourth as a constant. We will differentiate x to get 1, so 1 times 3 is 3, so I'll have 3y to the fourth. Now I'm going to find the partial derivative with respect to y, so differentiating z with respect to y, I'm finding the partial derivative. So it means I'm going to treat x as a constant. So differentiating y, I'll get 1. So 1 times x squared, that's x squared. So I go ahead and write my x squared here. Then I differentiate this part. So treating this as a constant, so differentiate y to the fourth, it will become 4y cubed, because we carry the 4 in front and then subtract 1 from the power. And I multiply 4 times 3, that's 12. So that means what I have here is 12xy cubed. Now, having these, I can now differentiate x with respect to t, and I also need to differentiate y with respect to t. So differentiating, I am going to have sine 2t, I need to differentiate. The differential of sine 2t is 2 cos 2t, so I'll have 2 cos 2t, while the derivative of cos t will be minus sine t. So I'll have this to be minus sine t. Now applying this rule, I'll write it below here. I will have the derivative of z with respect to t. I'll write the partial derivative of z with respect to x, which is this. And I will have 2xy plus 3y to the fourth, and the derivative of x with respect to t will be 2 cos 2t, plus I will differentiate z with respect to y, which is this. So I will have x squared plus 12x cubed y, and then I will have the derivative of y with respect to t, that's minus sine t. Now I can go further where I will expand the bracket. We can simplify this by clearing the brackets, and we can multiply 2 times cos 2t times 2xy. 2 times 2 is 4. So I'll have 4xy cos 2t. 2 cos 2t times 3y to the 4th. That gives me 6y to the 4th cos 2t. Then I multiply minus sine t times x squared. That gives me minus x squared sine t. And then minus sine t times 12x cubed. That's going to give me minus. And then I'll have 12x cubed y sine t. And that's it. The next question, if z is equal to x cubed y to the 5th plus 4xy cubed, where x equal e to the 3t and y equals sine 3t, find the derivative of z with respect to t. Now, what's going to happen here is just as before, I need to find the partial derivative with respect to x, as indicated here. So it means I differentiate x cubed to get 3x squared. So I have 3x squared here. Rewrite my y to the 5th. And then I differentiate x, it disappears. So I'll just have plus 4y cubed. The next part, I'll find the partial derivative of z with respect to y. So it means I treat x as a constant. So differentiate y to the 5th. I will get 5y to the 4th. But I like to write my number in front, so it's going to be 5x cubed y to the 4th. The next part, I am going to differentiate with respect to y. So this is going to be 3y squared. And then I multiply 3 times 4, that's 12. So writing this, I will have 12xy to the 2. Now find the derivative of x with respect to t. And looking at this, I will have to differentiate this, differentiating an exponential function. We differentiate the power to get 3. So we'll have 3e to the 3t. So writing this, I have 3e to the 3t. And my final one, where I differentiate y with respect to t, differentiating a sine function, differentiating 3t to get 3. So I put the 3 in front. And differential of sine is cos, so I'll have cos. Rewrite my 3t. So having this information, I can go ahead and substitute the partial derivative of z with respect to x. I will have this line being written. So going ahead, I will have 3x squared y to the 5th plus 4y cubed. And the partial derivative of x with respect to t, it will be 3e to the power 3t. Following that, I will have partial derivative of z with respect to y. So this is the next one that I'll write. So I'll have 5x cubed y to the 4th plus 12x y squared times the derivative of y with respect to t. I will have 3 cos 3t. So multiplying 3e raised to the power 3t. 3 3 is 9. So I'll have 9x squared y to the 5th e to the power 3t. Multiplying 3e to the 3t times 4y cubed. I'll have 4 3s 12 y cubed e to the power 3t. 3 cos 3t times 5x cubed y to the fourth. I will have 50x cubed y to the fourth cos 3t. And the final part, I multiply 3 cos 3t times 12x y squared. 3 12s 36, so I'll have 36 x y squared cos 3t. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have a question, you can leave a comment below or suggest a topic that you would like me to look at. Have a great day.